Hello, everyone. So I'm Simon Du, and I came from China, and my real name is Du Jinfang, and it's a great honor to be here to talk to everyone. I used to be a regular speaker to ClueCon and until before COVID-19, you know. So this year it's a great honor to be here back again, talk to everyone. I'm the top 5 contributor of FreeSWITCH. I contributed a lot of code. And this is the 20th ClueCon anniversary, and it's my 10th time to be here. And yeah, I like ClueCon. And I am the creator of FreeSWITCH Chinese Community. So freeswitch.org.cn. If anyone read Chinese, Mandarin, can go to there. And I write books. I write books about FreeSWITCH, Kamailio, and FFmpeg. And I use FreeSWITCH to create some commercial solutions. I built XSwitch, so it's basically FreeSWITCH and a UI. I made that in Docker and the cloud. And I also trying to make international company, maybe in the United States. It's called Cherry Code. So my company is, we are a sponsor of, we call it Xiaoyingtao. It's basically literally cherry, you know. And if you cannot remember that, just remember Apple. We're just similar, you know. And I also want to make some to see, you know, so CCall.ai is a personal AI agent and translation, and all cool things we're trying to build for that. So they all powered by Xiaoyingtao, my company. And when we talk connect to everything, I actually talk connect to everything about audio and video. For example, phones, SIP devices, WebRTC, IP camera, and conferences and GPT. Let's start from conferences. So everyone knows that we have different conference models like MCU. So traditional conference like FreeSWITCH and Polycom, Cisco, Huawei, they are MCU structure that they only send and receive in one stream, audio and video stream. So the client is really easy to build, and because they only can handle one stream. But the MCU, they need some power to decode and encode the streams. And modern conferences using so-called SFU, selective forward unit structure, like Zoom, Google Meet, Angora, whatever, so modern, that they send one stream but receive multi-stream. So they are more flexible on the client side, but it's a bit complicated to build a client. And another one is called mesh. So for MCU, both MCU and SFU, you know, it had a single point of failure, right? If MCU down and everyone get disconnected, but for mesh, there are some special use cases. So they can connect to each other with the network structure, but it's hard to control, hard to billing, right? So most conference systems are MCU and SFU. So FreeSWITCH is an MCU. As you can see, there are 4 cameras. They all capture 1, 2, 3, 4 different videos and send to FreeSWITCH. And FreeSWITCH will scale and decode and scale and reconstruct into a one video, one picture, and encode and send to everyone. So every client see the same view of the picture. And for example, there is 3 clients in the conference. But when you just at the same time you want to share your screen, right? So when you share your screen, that you will get this, something like this. So all modern conference clients, they did some trick. They did some trick that when you're sharing your screen, that you cannot see anyone else. So they did that clever, but that's also some trick, you know. And we actually using FreeSWITCH. The FreeSWITCH MCU is actually very powerful. I wrote the initial code, and Tony made a lot of improvements. And the FreeSWITCH MCU actually have different canvas. It's called canvas. So we put all the pictures on the canvas and send to everyone. And this is the particular use case that we use because in the scenario that for example, I'm talking on here. You can put my image on the main canvas. Then every client will see me. But when I want to see you. If you're listening, someone is sleeping there, right? So I can see, so all the clients, all the images from the clients, the video, we can put on the second canvas. So I will see the second canvas, and everyone see my main canvas. And there is also a third canvas, FreeSWITCH. It's mainly used for like monitoring. So for example, on the main Twitter, it can see all the canvas, what happened on all the canvases. That's very powerful. And we have some customer using that. And but our customer ask how many clients you want to handle. I see maybe 100, but our customer said that we want 1,000. So what we do is we did this. Then we made 2 layers of FreeSWITCH. That all the different clients connect to different FreeSWITCH. And we use FreeSWITCH as a client and connect to the master FreeSWITCH. So we can handle 1,000 users. So to make that easy, we do that. We put everyone. We put the main image to only to the canvas 1, and we can put everyone else so to the second canvas. So then we made that skill. And I see when I say that MCU only have 1 stream, actually it's not accurate. So nearly all hardware devices, they support a protocol called BFCP, right? Because it's called binary flow control protocol that everyone wants to see because I'm good, right? And but you also want to see the presentation. So BFCP allows you to see 2 streams on 1 device. Then, but you need to have 2 screens, right? You either have 2 screens or 2 different TVs. And so we also extended FreeSWITCH to support BFCP. That's BFCP is basically 2 video streams. And when in 1 SIP, it's 1 SIP call, but 2 video streams, 1 audio stream and 2 video streams. Then we did a trick. In Mod Sophia, we hijack the SDP and we split that into 2 SDPs. We create a fake channel. Then there's a real channel, SIP channel, and another child fake channel. Then the fake channel only has video stream. So we turn that into 2 calls, 2 different channels, and we put that in the dot plan, hit the dot plan, it can go to MCU. So we can get that in the conference. And we can also send different streams to somewhere like some SFU like Angora. And anyone know about Angora? Okay. So Angora is a Chinese-based company, and they also had headquartered in the United States. They basically made WebRTC a commercial product that they built a large network called real-time network. And They have SDK. I took their Linux SDK to put that in FreeSWITCH, and they also have Android SDK, iOS, WebRTC, whatever. So they are basically, as if you think about Zoom, right? We can make all the SIP phone connect to Mother Sophia, and and connect different streams to Mother Angora. And as you can see from this diagram that all the drive is from SIP. From SIP, there's one RTP sent to Mother Sophia. Then we use Angora SDK sent to the Angora SFU. So each stream will be one stream. And when Angora MCU get back, and because all the SIP devices only can handle one video stream, so we put the stream into the MCU, and it creates one picture and sent to the devices. That's how we bridge MCU to MCU. Another example is that anyone know about Tencent? Okay, Tencent is a company, a Chinese-based company that they have a conference like Zoom, that they also offer some SIP connection. What we did is that, but FreeSWITCH only has bandwidth in the AS field for video, and Tencent needs that as global, so global for video and audio. So we made some patch, and they are happy, and we can connect to their conferences. Another protocol is called it's called WIP. Anyone know about WIP? Okay, WIP is kind of WebRTC protocol. So WebRTC is media only, but if you want to join something, you need a signaling protocol. Either you use SIP or whatever. And WIP is just WebRTC signaling over HTTP. So you can make a HTTP port and send your SDP from the browser to FreeSWITCH. Then it will make a call. But WIP is one way only. It is from browser to FreeSWITCH. And there's another protocol like that called WAP. WAP is for access. So it will download the media stream from that. So if you make a two-way call like a real-time call that you need to create two different connections. We also extended that. We made that FreeSWITCH to support WIP and WAP. And we also invented another protocol called WAP. So you can use one SDP to do bidirectional conference connection. Yes. And everyone know that FreeSWITCH initially support WebRTC. It used SIP or WebSocket. So SIP is the standard protocol. And another protocol FreeSWITCH called Word2, and it's a FreeSWITCH only. And we support both of that. But there are some use cases that they want to broadcast. So FreeSWITCH only can support like 100 or 1,000, clients. But in some cases they want tens of thousands, users. They want to watch that, and they watch only, right? They are read only. So we also made some connection to SRS. So SRS is a open source broadcasting. It's basically like an SFU. So it can support millions of code conference stream. So we push that stream into SRS, and then from other client WebRTC or WeChat in China. It's a China social media. So we can everyone can look that. And another thing called Zero Media Kit is just like SRS. It supports a lot of protocols like RTSP, FS, LV, HLS, TS, FFmpeg, WebRTC, SRT, etc. So we push video streamed into their media kit, and every different client can see that. Another good thing is that we use that we push streamed into their media kit, and SRS is we can make that scale. You can use different FreeSWITCH server to push to one cluster, so everyone can see that. Another use case is that Microsoft Teams. We did a lot. We did connect to Microsoft Teams. It's audio only. We haven't made the video work, but the audio works. So Microsoft Teams has many ways to do with the SIP. It's called SIP Gateway, Direct Routing, RTMP, NDI, but everything is complicated. We made direct routing work. Basically, we need the SBC. We use the Kamailio as SBC because they have some weird request. FreeSWITCH doesn't support without changing code. We use, it must be TLS. It cannot be plain UDP or TCP. And it must use domain. And you must use record root. And you must use special contact. And it's only support ICE. And in the RCE, only support one candidate. It's weird. So FreeSWITCH by default has 2 candidates. We end up using Kamailio to kill one candidate, so we can connect to Microsoft Teams. And basically, this is the Kamailio Lua. We use Lua script. If we check out if the call comes from Teams, so we just make a pattern to detect if a call is coming Teams with regular expression. And when it comes from Microsoft Teams, we do some trick, like add a record root and whatever. And another one, this is the example that we kill the candidate. When you make a call from FreeSWITCH to Microsoft Teams, FreeSWITCH has 2 different candidates in the SDP, and Kamailio will kill one and then send that, remove one, and then send that to Microsoft Teams, so Teams will happy. And another thing that we use local contact. So we use some trick when TM local request. We change that to it cannot be IP address. It must be a DNS. So we just replace that from the SIP message. Okay, that's about Teams. Really some tricks, right? And another one is 4G and 5G VoLTE and 5G NR. You know, in the past days, both the OpenShift and the Kamailio guys, Elena showed that how the 5G works, right? But it's really complicated. So telephony on the phone is actually a first citizen on phone. So how many people using your phone to make a call? Okay, someone, right? But mostly you use your phone to use Facebook, right? TikTok or whatever. But phone is actually, you don't use that much. But telephone is first citizen on the phone. Whatever you are working, if a phone call is coming in, you must answer the phone call, right? Or reject it, right? So it's a first citizen. And all the 5G phones have video support, so you can directly making video call or join a conference, and it can do video upgrade. So you can make an audio call, and then you can switch without hanging up the call. You can switch to a video call, and it has a quality of service and video early media and video, you know, conference. It's very powerful, but you know, it adds some hard. Basically, the SDP, you need RTCP to manage bandwidth. So you need AS, RSRR, and you need reinvite to and update to make the audio-video upgrade. And you have to add something like the QoS and the SDP to make SDP offer and answer to negotiate for the bandwidth. You need some preconditions and 100 reliability to make that work. To do that, we really patched a lot to FreeSWITCH. So this is the basic SIP message. Everyone already familiar that you can invite an SDP and 200 OK and ACK, right? But for in the 5G network, you have to do something like this. You have to do PR ACK. You have to update, and the UAC will update for video, and the US will update too. So it's very complicated. But basically, it's a SIP. Another use we use in China is mostly GB28181. It's a GB8 national standard in China, and we can connect to cat camera. And the old cat camera, they all use protocol like RTSP, right? But we have this GB protocol is SIP based. But it's weird. They use RTP and they use H.264 for video, but they put that in the PS packet stream. It's not playing RTP, so it's hard. We end up created a mod PS to decode that. But everyone wants to connect to AI, right? Nowadays, if you do not do AI, you are outdated. So for AI, there are basic two different protocol. It's called MRCP. And MRCP is an old protocol for ASR and TTS, and it has two different versions. Version 1 is RTSP based, and version 2 is also SIP based, but it's different than plain SIP. But MRCP is not built for today's structure. It's very hard to make that in a cloud native way. So nearly every provider, the ASR, TTS, they all use the WebSocket protocol to create their service. For example, we end up made each one made a model in FreeSWITCH. So we can connect to them with the WebSocket. It's in China, it's Ali, iFly, Baidu, Huawei, and in the United States we use Google. Google is using Google RPC. It's not using gRPC. Is not WebSocket, and Microsoft. And to connect to ChatGPT, we actually made another thing that outside of FreeSWITCH to control. So ChatGPT mainly the protocol is mainly HTTP, but it's a long connection, and they use SSE, server sent event, to send a generated word one by one, right? So you have to handle long connection, and because the generative is very slow, and you cannot wait. ChatGPT give you all the sentence and then do TTS playback. So when we did one trick, we called segment. We split that according to punctuation. Whenever we received a punctuation from ChatGPT, we send to TTS, then stream that out. So it basically works. And we made some experiment. We changed the model Lua. So in Lua, you can connect to ChatGPT and inside FreeSWITCH, and basically on input callback is a callback. When you press DTMF or when you do detection, ASR detection, it will hit this callback. And we add another callback called GPT callback. And you can use, whenever you connect to GPT, there's some back, we can use the GPT callback to trigger TTS. And then you can use Lua inside the FreeSWITCH and to talk to ChatGPT. One last thing is the digital avatar. Yes, this is made a few years ago because it is outdated. All the modern stuff works better, and all the services, they made that the lip sync to be very very precise, but we actually make cartoons. Why you make the lip sync, right? So this is the cartoon I recorded from
你好，欢迎致电烟台
from
小樱
iPhone
桃网络科技有限公司。
So I can record that as a video and using TTS to trigger that. Whenever I detect the TTS, I fast forward to the frame that start speaking. So
欢迎致电烟台小樱桃网络科技有限公司。烟台小樱桃是高新技术企业，坐落在美丽的黄海之滨，让互联互通更顺畅，让实时互动更高效。小樱桃将竭诚为您服务。
sorry, that's Chinese. So we just use the TTS to trigger that. We just forward to the that's when it talk. Okay, so a summary of making models. A lot of people ask you making models with FreeSWITCH, right? So how can I get the audio out from FreeSWITCH? So basically, there are different methods. You can write an endpoint model like a SIP, WebRTC, or you can use ASR TTS model. They can access to media, and you can actually write a codec like what I did in mod PS. And actually, you can do a media bug on a call. So media bug, when you make a call through FreeSWITCH, you can add a T. So media bug is not a bug. It's like a T. So you can hear sound from that. So you can send that out with whatever protocol. You can write a model from there. And also application like playback, record, they all can access access audio data. But if you want to do one leg the code, you can write an application to get all the data. So okay, so basically that's all of connect everything about audio and video. So we can connect to phones, SIP, WebRTC, camera, conference, GPTs. Let's connect to everything. Thank you.
Thank you, Seven.